Welcome back, everybody. Ready for another deep dive? Today, it's all about Alessandro Volta.
Volta, the battery guy.
Yeah, you probably know the Volti because of him, but I bet there's a lot more to his story than you realize.
I'm sure you're right.
So, to really get into it, we've got some excerpts from a biography about him, ready to go.
Oh, cool. A whole life to explore.
Yeah. And from what I've seen, Volta's life had a little bit of everything. Intrigue, rivalry, even some explosions.
Explosions.
You'll see. But let's start at the beginning. Volta was born in 1745 in Como, Italy.
Okay, Como, Italy. Got it.
And his family, they were nobility.
Oh, so not your typical struggling inventor then.
Not exactly. More like born with a silver spoon kind of thing.
Interesting. Must have made his path into science a little different.
You'd think so, right? But let's just say Volta didn't exactly follow the path his family laid out for him. Instead of going into the seminary like they wanted, he went straight into science.
Really? He just skipped seminary.
Yeah, seems like he had other passions. And by 1774, just 29 years old, he's already a physics professor.
Wow, 29. Professor.
In Como. Clearly, the guy was brilliant from a young age.
That's impressive.
So, I was reading about this electrophorus thing. Did he actually invent this?
The electrophorus. That's where things get a little tricky. Volta gets a lot of credit for the electrophorus, but actually he didn't invent it. He just made it better, more efficient, more popular.
So he improved upon an existing design.
Exactly. And it's actually kind of a good lesson, right? Like,
Yeah.
even the most brilliant minds, they're often building on what came before. It's like what's that phrase? Passing the torch.
Yeah, passing the torch, absolutely. So what was this thing? Anyway, what did it even do?
Okay, so basically, it was a way to make static electricity.
Static electricity, like when you rub a balloon on your head and it sticks up?
Exactly. But, obviously the electrophorus was a bit more sophisticated than that. It allowed scientists to create these static charges, experiment with them, which back then was a pretty big deal.
I can imagine. No iPhones back then to distract them. So it seems like Volta's really fascinated by this whole electricity thing, right? Even as a young professor.
Absolutely. And that fascination leads him to some interesting places, like
Yeah.
into the world of gases.
Gases.
Yeah. He was inspired by Benjamin Franklin's work. Remember Franklin? With his flammable air.
Flammable air.
Yeah, that's what they called hydrogen back then. It was like a new frontier.
Hmm.
And Volta, being Volta, he's got to explore it.
Okay, so we've gone from sparks to flammable air. Where does this lead him?
Well, in 1776, he's out there poking around in the marshes of Lake Maggiore, just doing some field research, and he discovers methane.
Methane. Like what comes out of cows?
Well, yeah. But also remember, this is the 1700s, right?
Mm-hmm.
They didn't really understand gases the way we do now. So for Volta, it's a big discovery. He actually figures out how to isolate it.
So he's basically playing with swamp gas.
Hey, he was a scientist. And by 1778, he even manages to ignite methane in a closed vessel using, you guessed it, an electric spark.
Wait, so he's deliberately setting off mini explosions?
Well, yeah, kind of.
Mm.
But that just shows how curious he was. He wasn't afraid to get his hands dirty, literally, even if it meant a little bit of risk.
I love it. He's like a scientific daredevil. But how does all this connect back to his work with electricity? With batteries, I mean?
Good question. You see, Volta wasn't just messing around. He was building a foundation of knowledge. So all this work, the electrophorus, the gases, it all starts feeding in to his understanding of electrical capacitance.
Capacitance. Can you break that down for me? It sounds kind of technical.
Sure. Think of it like this. Capacitance is how much electrical charge something can hold. Like, imagine a bucket. The bigger the bucket, the more water it can hold, right?
Yeah, I get that.
Well, capacitance is kind of like the size of the bucket for electricity. And Volta figured out ways to study both the electrical potential, measured in volts,
Yeah.
and the charge itself. Like how much water is in that electrical bucket, so to speak.
Okay. So more charge equals higher potential. Bigger bucket, more water.
Exactly. And his big discovery was that for a given object, the voltage and the charge are always proportional. This is Volta's law of capacitance.
Volta's law. So that's where the unit volt comes from.
Right. It all ties together. And this idea of capacitance, it's crucial for developing batteries, for understanding how electricity behaves.
Makes sense. Like, got to figure out how much fuel the car can hold before you can design the engine, right?
Exactly.
So Volta is laying the groundwork here for some major breakthroughs. But before we get to the famous Voltaic Pile, the battery, there's this whole rivalry with Galvani we got to talk about. What was that all about?
Yes, the Volta-Galvani rivalry. Now we're getting to the good stuff.
Yeah.
So Volta takes a new job in 1779, professor of experimental physics at the University of Pavia. Pretty prestigious. And it's there that he meets Luigi Galvani, another Italian physicist.
And what's Galvani doing? Is he working on batteries too?
Well, he's definitely interested in electricity, but his approach is a little unconventional. He's experimenting with something he calls animal electricity.
Animal electricity, like what? Electric eels or something?
Not quite. Think more along the lines of frog legs.
Frog legs.
Yeah, so Galvani's doing these experiments where he connects two different metals to a frog's leg, and the leg twitches. He thinks the electricity is coming from the frog itself.
Wait, he thinks the frog is the battery?
Well, essentially, yes. But Volta, he's not so convinced. He sees something different happening in those frog legs, something that's going to change our understanding of electricity forever. But that's a story for part 2 of our deep dive.
You're going to leave me hanging like that, come on.
Got to keep you coming back for more. See you next time. Okay, so last time we left off with Volta and Galvani. Kind of a scientific showdown, right? Galvani's got his twitching frog legs. Volta's not buying the whole animal electricity idea.
Yeah, it's one of those classic scientific rivalries. Two brilliant minds butting heads over a big question. And this is where Volta really starts to shine. He doesn't just dismiss Galvani's work. He takes it apart, tries to figure out what's really going on. So Volta's basically playing detective with these frog legs. What clues does he find?
He starts to realize that the frog's leg itself isn't actually the source of the electricity. It's more like a conductor, a detector, like a wire that also happens to twitch.
Ah, okay. So the frog is more like a biological voltmeter?
Exactly, a living instrument. And Volta figures out that the real key here is the TWO different metals Galvani's using. That's what's creating the current.
So he's saying the frog is just a middleman, a go-between for the metals.
You got it. And to prove his point, Volta gets rid of the frog altogether. No more animal electricity needed.
No more frogs. How does he do that?
He replaces the frog leg with something else that can conduct electricity, some brine-soaked paper. Basically just salty water.
Salty paper. And that works.
It does. He still gets a current flowing, no animal tissue needed, which proves his point. The electricity isn't coming from the frog. It's coming from the interaction between the metals and the electrolyte.
Whoa. So Volta debunks this whole animal electricity theory. Must have been a pretty big deal back then.
Huge. It completely changed how people thought about electricity. Before this, a lot of people thought electricity was something special about living things, a vital force, you know.
Like some mystical life energy.
Exactly. But Volta showed that, nope, you can create electricity just with chemistry. No magic required. Opens up a whole new world of possibilities.
I bet that didn't make Galvani very happy. Did he ever admit Volta was right?
Galvani. He actually kept defending his animal electricity idea even after Volta's experiments. It's interesting, right? Even in science, where we're supposed to be all about the evidence, sometimes it's hard to let go of your own pet theories.
Makes sense. So where does Volta go from here? He's figured out it's not about the frog, it's about the metals. This is how he gets to the battery?
You bet. He starts experimenting with all kinds of different metals, figuring out which ones react more strongly, which ones create a bigger electrical push.
Okay, but how do you measure that? How do you know which metal is more reactive or whatever?
That's where the electrochemical series comes in. It's this ranking of metals based on how easily they lose or gain electrons, kind of like a hierarchy of electrical potential.
A hierarchy, okay. So some metals are at the top, some are at the bottom.
Right. And the bigger the difference between two metals on that list, the stronger the electromotive force between them.
Electromotive force, is that like the oomph behind the electricity?
Yeah, exactly, the driving force. And Volta realized if he could connect a bunch of these metal pairs together, each separated by an electrolyte,
Yeah.
he could create a continuous flow of electricity.
Hold on. This is starting to sound familiar.
It should, because that's exactly how he invented the Voltaic Pile, the first battery.
That battery, finally. I remember making a simple Voltaic pile in school, just stacking some metal discs with salty cardboard. Seemed like magic, making electricity appear out of nowhere.
It really is pretty simple design when you get down to it. Volta used zinc and copper for his discs, two metals with a pretty big difference in their electromotive force, and he separated them with pieces of cardboard soaked in brine. That's your electrolyte.
So salty cardboard is all you need.
Pretty much. Of course, Volta figured out the exact arrangement, the best materials, all that stuff. But the basic principle is that simple. You stack these metal pairs up, and bam, you've got a battery.
But how does it work? What's actually going on inside that pile?
It's all about the chemical reactions happening in each metal disk. So at the zinc disk, the zinc atoms start losing electrons. That's called oxidation.
They're giving up electrons. Why?
Because of the chemical reaction with the electrolyte. And those electrons, they need somewhere to go. So they flow through a wire or whatever you've connected to the battery. That's your electric current.
Okay, so that's one side of the battery. What about the other side with the copper?
At the copper disk, it's the opposite. Hydrogen ions from the electrolyte, they come along and grab those electrons. That's called reduction.
So the zinc is losing electrons, the copper's gaining them, and that creates the flow.
You got it. And the salty cardboard, the electrolyte, it acts as the bridge between them. Make sure those ions can move around so the whole reaction keeps going.
It's like a tiny chemical factory churning out electricity. No wonder everyone was so excited about Volta's battery.
It was a revolution. For the first time, people had a reliable, continuous source of electric current. Scientists could do all sorts of new experiments. It was the beginning of the electrical age.
But these early batteries, I imagine they weren't exactly perfect, right? Weren't they kind of dangerous?
Oh yeah, they had their drawbacks. For one thing, the electrolyte Volta used was often sulfuric acid. Pretty corrosive stuff, not something you want to spill on yourself.
Yeah, I can imagine there were a few lab accidents.
I'm sure there were. Another problem was that the battery's power would fade over time. The hydrogen gas that got produced at the copper disk, it would start to build up and block the reaction.
So not the kind of battery you'd want to carry around in your pocket, but still a huge breakthrough.
Oh, absolutely. And Volta, he was very humble about it.
Yeah.
He always made sure to credit other scientists who had influenced his work, guys like Nicholson, Cavallo, Bennett.
He knew he was standing on the shoulders of giants.
Exactly. And that's another good lesson, right? Even in science, it's all about collaboration, building on each other's work.
So Volta's created this amazing invention. Word's getting out. People are starting to understand what he's done. What happens next?
Well, he gets pretty famous pretty quickly. I mean, even Napoleon Bonaparte gets interested, invites Volta to Paris to demonstrate the Voltaic Pile in person.
Wow, from frog legs to emperors. That's quite a journey.
It is, but there's actually one more layer to this story, something you might not expect given everything we've talked about with science and electricity. It's about Volta's faith.
Welcome back, everyone. So we've been exploring the life of Alessandro Volta, the man who brought us the battery, the Volt. And as we've seen, it's quite a story.
It is, full of twists and turns, from sparks and explosions to, frog legs.
Yeah, who knew frog legs would be so important for the history of electricity? But before we wrap up our deep dive into Volta's life, there's one more thing we need to talk about. Something that might surprise you.
You're talking about his faith, right?
Exactly. Volta was, throughout his entire life, a devout Catholic.
Yeah, that always gets me. You've got this guy revolutionizing our understanding of electricity, a force of nature that people barely understood back then. And yet, he's deeply religious.
It seems kind of paradoxical, right? Science and religion, like they're supposed to be opposites. But Volta, he didn't see it that way.
No, not at all. He actually believed that science could help his faith, like studying God's creation in a deeper way.
There's this quote from Volta that I found really interesting. He said that looking at the arguments for and against religion actually made his belief stronger, gave it, quote, a degree of probability even for the merely natural reason.
Whoa, that's deep. So for him, it wasn't just blind faith. He thought about it, reasoned it out.
Yeah, it wasn't just about accepting what he was told. It was about exploring his beliefs, questioning them, and ultimately coming to his own conclusions.
I mean, that's what science is all about, right? Questioning, exploring, finding evidence.
Exactly. And I think Volta's story reminds us that scientists, they're not all atheists or agnostics. It's possible to embrace both science and faith, to find meaning in both.
It's a good reminder that people are complex. We can hold all sorts of different ideas and beliefs at the same time and find truth in all of them.
So as we wrap up our look at Alessandro Volta, we're left with this picture of a man who was both a brilliant scientist and a devout Catholic. A man who not only changed the world with his discoveries, but also challenged our assumptions about the relationship between science and religion.
Absolutely. He really shows us that those two things, science and faith, they're not necessarily at odds. They can coexist, even complement each other.
And if a guy from the 18th century could make such groundbreaking discoveries with the limited technology they had back then, imagine what we can do today.
Right. The possibilities are mind-blowing. Volta's story should inspire all of us to keep exploring, to keep asking questions, to never lose that sense of wonder.
So next time you flip a switch or charge your phone, take a second to think about Alessandro Volta. the man who helped electrify our world and whose life shows us that the pursuit of knowledge, in all its forms, can lead to a richer, more fulfilling life. Thanks for joining us for this deep dive.
Yeah, thanks everyone.